Hello and welcome. Welcome to week 2. So today I'm going to talk about some solution stuff. We're going to talk about what happens when we start mixing chemicals together. So we've been talking about intermolecular forces up till now, talking about how molecules interact with themselves. Now we're going to start mixing chemicals together and talk about how they interact with other chemicals and create solutions. Okay. So um, when we talked about intermolecular forces, what we talked about was that intermolecular forces are molecules interacting with themselves, right? We have partial positives, we have partial negatives. Those are attracting each other, creating these attractive forces that kind of hold molecules together. Depending on how strong they are, they can hold them together really tightly, like in solids. They can hold them together not at all, right? They can be not strong enough to hold them together, and that would be something like a gas. But what happens when we put two different molecules together, right? Each molecule is going to have dipoles of some kind, whether it's the strong dipoles of hydrogen bonding, the intermediate dipoles, or the kind of temporary dipoles of dispersion forces. And so we're creating these positives and negatives in both types of compounds. What happens when we mix them together? That's what we're going to talk about today. All right. Let's see if I can get my pen going here. Not going to let me do it. Here we go. Okay. So let's take an example. Let's mix water and methanol. Right, so if we look at the chemical formulas that we're looking at, we have water, which is of course H2O, and we have methanol, which has 3 hydrogens on this carbon, and then we have an OH group over here. Right? And so right away, what you're thinking, having just spent some time with intermolecular forces, is immediately you identify that both of these compounds have hydrogen bonding going on, right? Both of these have the strongest intermolecular force that we're going to ascribe to each of these is hydrogen bonding. So the question is, can they hydrogen bond with each other, right? Instead of having water only interact with water and methanol only interacting with methanol, what happens when we mix these together? And the answer is that they interact with each other, right? Water has a dipole where this oxygen is a delta minus, this hydrogen is a delta plus, right? Because the oxygen is more electronegative than the hydrogen. This is hydrogen bonding. And if we look at methanol, right, methanol does pretty much the same thing where the oxygen has a delta minus, the hydrogen has a delta plus, and we can imagine very easily that these pluses and minuses are going to line up in such a way that each of them is going to interact and be attracted to its opposite in the other molecule. And so when we have mixtures like this, what's going to happen is some of the water molecules will associate with methanol molecules, and some of the methanol molecules will associate with water molecules. So what we're doing is we're introducing kind of a third intermolecular force, right? We have water, which we know can interact with water, right? And this is mostly through hydrogen bonding. We have methanol, which we know can interact with methanol through hydrogen bonding. And now we have a third force, right? We have water interacting with methanol. And yet again, we have more hydrogen bonding. Right? And so we have hydrogen bonding that's going on. We're increasing the number of hydrogen bonds that can be formed because methanol can now interact with water. But the thing also to remember is that every time that we have an interaction like this, water and methanol, that means that this methanol molecule is no longer associating with other methanol molecules. So when we have a solution, we have two parts of the solution, right? This is a little bit of a odd example because these are both liquids, but we have a solvent. Right? The solvent is the liquid, and then we have a solute, which is usually a solid, but other times it's just kind of the thing that's there in a lesser amount. Right? We have a solid and a liquid. And so we can rename all of these things as more general types of interactions. So every solution, a solution is a mixture of these two. Solution is a mixture of solvent and solute, right? So we can look at this and say, so water to water, that is an interaction of the solvent with itself. So solvent-solvent interaction. Right? Methanol to methanol is a solute to solute interaction. And then the water and methanol interaction is solvent interacting with solute. In order for a solution to be made, in order for a solid to dissolve in a solvent, right? This has to be the most common, the strongest intermolecular force. If this is strongest, we get a solution. Okay. So when we identify these intermolecular forces, now we're going to apply them a little bit more broadly. We're going to look at, can water molecules basically pull solute molecules, methanol molecules, away from each other, right? We want to break, so if the solvent-solute things are stronger, we're going to break these solute-solute interactions and separate the methanol from itself and create a solution. So this is an example where this works because we have kind of similar things going on. We have hydrogen bonding all over the place. I do want to look at one example where this wouldn't work. So let's look at, sorry, give me 1 second. I gotta get my pen back here. Okay, I got my pen back. So let's look at the mixture of water and ethane. So now ethane is not a solid, but we'll ignore that for now. All right, so same analysis, right? We have solvent-solvent interactions. That's going to be water interacting with itself. We know what that looks like. That's going to be hydrogen bonding, right? We also have solute-solute interactions, and that's going to be ethane interacting with itself, and we know that that looks like dispersion forces. It's hydrogen bonding. And so the question is, do we get solvent-solute interactions, right? Can we have a water molecule with its big old dipole interact with ethane that has no dipoles, right? There are no partial charges here. On this, and so there's nothing to attract ethane to water, and so this solvent-solute interaction between a very strong dipole and basically no dipole in ethane doesn't really gain us anything. And so if you mix ethane, or which is basically just gasoline, right? If you mix gasoline and water, what you get is not a solution. You get two separate layers of these things. They don't mix together. And so there's no attraction between the strong dipole, right, water, and the neutral atoms of ethane, right? And so this is basically what solubility says. Solubility, the main rule of solubility is that like dissolves like. If you want your solvent-solute interactions to take over and break up your solute-solute interactions, you need to have the same types of intermolecular forces in your solvent as you do in your solute, right? So this is why polar molecules, molecules with dipoles, polar solvents dissolve polar solutes. Right? So if you want to dissolve something in water, water has very strong dipoles. The things that are going to dissolve in water are other things with dipoles because it has to have something for that water to attract to. And the opposite is also true, right? Um, and the opposite. If you have two things that don't have any dipoles in them, things that are only dispersion forces, those dispersion forces, it doesn't really care uh, which molecule it's interacting with. So if you have a solvent that has only dispersion forces, like gasoline or kerosene or something along those lines, right? If you have a solvent that's nonpolar and a solute that's nonpolar, those two things will dissolve each other as well, because the dispersion forces will work together to do that. Okay, so that's the solutions in a nutshell. Solutions are basically two compounds that whose intermolecular forces work together. So where we're going to go from here, we're going to look briefly at the entropy of a solution. We talked about entropy in the very first or second video, right? We're going to talk about the potential energy of solutions and whether that's a good situation for chemical reactions or not. And then we're going to talk about how much of something can we dissolve in it and how do we measure that. And we're going to get to do some actual calculations and such. So stick around for the next one. The next one we're going to talk about entropy. It'll be a short video, but it'll get to why solutions are so important when we start to talk about chemical reactions.